Hello everyone. Today we are going to start the next topic of the chapter relational functions, which is functions. So let us look at this topic. A relation is a function when every element in domain have one and only one image in range. So all the functions are relation. But if a relation is a function, then it should satisfy the condition every element in domain have one and only one image in range. So to make it easy to understand, just domain means the value of x values that we substitute in the function. Range means the output values we get when we substitute some value x inside the function. So you have to consider domain of the function as a house. Okay, got the point. Consider it as a house. The house has only one main door. In the same way, if we put one x value, we will be getting only one y value, not more than one. Okay. For every one input, we are getting one output. Or every house has only one main door. The same way, a domain has only, for every value of domain, every different value of domain, there is different value in range. Okay, that is the main point. If a relation is function, that condition must be satisfied. So let us discuss some examples so that you can understand the concept of functions. So these are some kind of questions that you should solve now. So identify whether the following arrow diagram depicts functions. Here you can see this is domain and this is range. Okay, so here one has a image 4 and one has a image 5. You have to consider domain as a house. Any house contains only one main door. So all the values of x are 1 houses. So here one has two doors, that is two values. If we put one inside a function, that is not practical. So it is not a function. Got the point. Second one. Here you could see 1 is mapped to 4. So f of 1 is equal to 4. Okay. F of 1 is equal to 4. And 2 is mapped to 5. Implies f of 2 is equal to 5. But here 3. The element 3 is not mapped to any of the element in the codomain. That means that 3 has no image. 3 has no image. But the condition says that every element in the domain should have a image. Therefore, this is also not a function. First one is also not a function since one has two images. Okay, so not any value in the domain can have two images. That is the basic condition that you should remember. And every element in the domain should have images. Okay. Not any element in domain, D means domain, should have two images. Okay, next one. Every element in domain should have single images. Okay. These are the main points that relation should satisfy to become a function. Next one. Here you can see 1 is mapped towards 2. That is f of 1 is equal to 2. F of 7 is equal to 3. And f of 4 is also equal to 3. So here all the elements in a domain have images in the codomain set or in the range images in the second set. 1 has image 2, 7 has image 3, and 4 also has image 3. Two elements in the domain may or may not have same images. That is, here you can see 7 and 4 are pointing towards 3 itself. That means they have same images. That's the point. It can have, cannot have. It is not a condition for a function. So if it have also, it is don't have also same images, it is not going to create any problem. Therefore, it is a function. Third choice is a function. Fourth one, the same way. A has image 4, B has image 7, C has image 7. That is f of A equal to f of B equal to f of C, C equal to 7. That means each element in the domain has image. That is the condition. Each element in the domain, okay, look here. Every element in domain should have single images. It has single images itself. Okay, but all the elements are having same image. That is 7 itself. That is not a problem. Hence, there it is a function. Next, here you can see another problem. Another problem, not another topic. Types of functions. So mainly we have to learn 4 types of functions in the class 12 syllabus. Okay, so you can see the first one is 1, 1. Different x values should have different y values. Then the function is said to be 1, 1. Okay, different x values. X values means the input values. Y values means the output that we get. So then the function is called 1, 1. Another name of 1, 1 is injective. Okay, my dear students. For example, if I consider arrow diagram, please look here. 1, 2, 3, 4. Is this a function? Yes, this is x and this is y. Okay, all the x values, all the values in domain have some image. But here the condition for is this function a 1, 1 function? Let us see. Condition, different x values should have different y values. Then function is 1, 1. But you could see that here x, f of 1 and f of 2 are equal to what? 3. That is, different x values should have are having same y value. That means it is not a 1, 1 function. This kind of function is called many one. A function which is not 1, 1, that is different x values have same y values. Here it is satisfying the condition of many one. So this function is many one function. Clear? So let us write an example for 1, 1 function like this. See here, 1, 2, 3, 4. It is x values and this is y value. So 1 has an image 3, 2 has an image 4. All the elements in the domain have some image, therefore it is a function, and they are having distinct images, therefore it is a 1, 1 function. And it is the first example is a many one function. So, and the condition that you have to prove while solving any question regarding 1, 1 is, you have to first of all assume let x1 comma x2 belongs to the domain of any function f of x. So we are assuming two values in the domain. Let that be x1, x1, x1 and x2, such that f of x1 is equal to f of x2. So if we are substituting two values in domain and x1 is x1 and x2, we are getting the same value as an output, then x1 should be equal to x2. Then only the function is said to be 1, 1. If x1 is not equal to x2, then the function is many one. If x1 not equal to x2 and satisfies this condition, then the function is said to be many one. Clear the idea? Yeah. Next topic. Next is onto function. Onto function. Every element in codomain should have pre-image in domain. Then function is onto, and another name of onto function is surjective function. So I have here drawn a arrow diagram, you may look here. So 1, 2, 3, 4, 5, 6. Every element codomain. This is codomain. The second set is codomain. Should have a pre-image. So 4 has a pre-image 1, 5 has a pre-image 2, and 6 has a pre-image 3. So therefore, it is a what? Onto function. So the condition that you have to prove during question is codomain is equal to range. Oh, and one more condition, f of x equal to y. This condition you have to prove. So onto function is clear to you, I hope so. Next function is into function. Into function, at least one element of the codomain has no pre-image. Here you can see that P has a pre-image A. Okay, and here R has no pre-image. Therefore, it is what? Not onto, or it is called into function. Not onto or into function. So next one is bijective function. A function which is 1, 1 and onto, that is injective and surjective, is called a bijective function. Okay, so a function which is both 1, 1 and onto is what you call a bijective function. So next you have to remember that if a function is bijective, then inverse of the function exists. Else the function is not invertible. So inverse of the function. Let me consider an example, then it will be more clear to you. 8, 12, 16. 1, 2, 3. It is a function. Since each element in domain have some images, you have to check whether it is a bijective function. So different elements, 8 have a image 1, 12 have a image 2, 16 have a image 3. Those different elements have different images. Therefore, it is a 1, 1 function. Next, onto. Every element in the codomain has a pre-image. 1 has a pre-image 8, 2 has a pre-image 12, 3 has a pre-image 16. Therefore, it is onto also. Since the function is onto and 1, 1, the inverse of the function is. Inverse means what? Here, if this is the x values and these are the y values in this function, f. In the case of f inverse, the y values will be the x values, that is 1, 2 and 3. And the x values will be the y values 8, 12 and 16. So if you substitute f inverse of 1 will be equal to 8. Inverse means going back. Opposite. Just opposite. Writing the point. And f inverse of 2 will be equal to 12. F inverse of 3 is equal to 16. Okay. Since we know that, you are getting f of 3 is what? 16. Okay. So, sorry, f of 16 is equal to 3. So, f inverse f of 16 is equal to f inverse of 3. So, f inverse f of 16 is what? Nothing but 16. F inverse of 3 is equal to 16. Okay. Inverse of the function means that is invert. Just the reverse it will happen. Range will be coming. So that is why it should satisfy a condition, that bijection condition. If the function is not bijective, what will happen is that, so let us consider a function which is not bijective. Then only you can easily understand the concept. So see here, I'm going to consider some function. 1, 2, 3, 4, 5, 6. Okay. Here, It is a function. Different elements have some images, but it is not a one function, since two elements are having same images, and it is also not a non-two function. So if we take the inverse, the all the y value codomain will be becoming domain. Okay, 4 5 6, and domain will be becoming codomain. So you could see that, see, inverse in case f inverse 4 will be equal to 1, f inverse 5 is equal to 2, and f inverse 3 will be also equal to, so this way you'll be getting. Here you could see 2 arrows are marked towards 5. So if in the case of f inverse, 2 arrows will be marked from 5. That is, one element or one door is one house is having two main doors. It is not possible. That means it is not a function. So if it's not a function, in case of a non-bijective function, f inverse does not exist. Okay. Hope the idea is clear to you. Next, composite function. Next topic and the last topic of the chapter, composite function. Composition of function means it is a function of a function. So let us consider three sets. Let us consider a function f which is from a to b, f defined from a to b, and another function g which is defined from b to c. Yeah, okay. So it is what? So you will be getting f of x will be the set B. Okay. When I substitute x, some value x from this set A, so I will be getting what? Y is equal to f of x. That y here, the codomain of the first function f is acting as the domain of the second function g. So I will be substituting g of f of x. So g of f of x means f composition g. That is g of f of x, which is denoted by g this way. Clear? And you did not remember the definition and all, since most of it is not that much prioritized topic. Not that much questions are asked from this. So you just remember this formula, this format. Composition means g of f of x. That or function and a function. Function of a function is what you call composition of functions. So just what you call composition of a function. So it is about 20 minutes since we have started the class. In the next class or next last part, that we will be doing some questions. Only 4 or 5 questions I will be taking from the exercise section. Since we have separate videos of PYQs, I will not be doing that much questions in the concept videos. So this much is the concepts of this chapter. If you like the video and the teaching, please subscribe, share it with your friends. So that's all. So remember about composition, different types of functions, different types of relations, and their conditions, which are helpful for you to solve questions. These are the questions which I am going to do in the next video. Okay then, bye.